Hi, and welcome to, I guess it's 11.3 Ohm's Law Lab. In today's lab, we're going to use a PhET simulator. So as you can see, just follow all the instructions very carefully. You're going to use this PhET simulator, but don't skip the objective. So the purpose of this lab is to examine the relationship between current, voltage, and resistance in a circuit. So now we're actually going to be constructing a circuit. You can click on this link, or you could just type in Google or Bing circuit construction kit DC only. So I already did that. Oop, and I'll go back to show you what it looks like. So hopefully you get to this page, no problem. And then what you do is you click on the picture with the little play icon there. You click on that, and it might pop up on the bottom. It's probably going to say, like, do you want to keep or discard that you keep it, or like trust it, all that stuff. So you might have to click through a couple things first before you get to this point now. So, but that's the first step, is to click on the play icon. If you need help doing that, you could email one of your teachers. So then it says in part one, lab, not intro. Again, all the instruct is very condensed down. I made this lab to fit on 2 sheets, and I had to condense a lot of information in here. So you're going to click on the lab. It looks like it's hidden in that little thing, but everything's important on the sheet. You got to read carefully. All right, so now this is what the interface looks like. We can make it a circuit. And it says create a simple circuit that includes the following items: wires, which connect all the elements in one loop. So you just want one loop, and I'll show you what that means. You're going to have a switch, a resistor, a battery, and an ammeter, not the non-contact ammeter. I mean, I guess this has been, well, whatever. So we'll do like, we need a battery, we need a switch. What else did it say? A resistor or a bulb? What does it want? A resistor. And it seems like we're like in the contact ammeter, not. So there's 2 ammeters. This one is the non-contact one. You could use either one. This one's harder to put in. I'll show you both. It's not a big deal. We'll put this one in our circuit for now. Is that it? That's all we need? Yep, I think so. And then some wires. So the way this works is you want to arrange them, however you want. Boop boop, beep beep, bop bop. Maybe I'll put the ammeter over here so we can read it. It's not like horizontal. Okay. Then the wires, you just connect one end to the other end here, but I kind of like making mine. It's a little extra, but it makes it look nice. All right, so I like to have corners, because that's how you want to draw your circuit diagrams, is the wires make right angles with each other. It's very boxy. So, and the purpose of that is you want to make it as clean as possible to see what's going on. You don't want like wires going everywhere. It's kind of like a convention, like you're following the rule of, okay, we're connecting these things. If the wire needs to make a turn, make it a right angle. Okay. So that's what it looks like. And if you click on the switch, current starts to flow. The little electrons are flowing, and the ammeter reads 0.9 amps. Okay. Just so you know, the other one that we were talking about, you could just, I kind of like this one better. You could say at this position, it's 0.9 amps. What do you think the current's going to be through here? Remember, current is the rate of flow of electrons, of current, of charge, I mean. So does it look like there's a different rate of flow of charge anywhere? What do you expect the current to be up here? It's the same thing. Pretty boring. All right, but when we do parallel circuits, it might be different. But in series circuits, it's all going to be the same. So this is kind of like a cool little intro to series. But that's not what we're talking about. We're going to look at the voltage, the current, and the resistance. So step number 2, it says draw the diagram of the circuit in the space to the right using the symbols in your reference table. Note, the black side of the battery is the negative terminal. Okay, so let's see how we have it. All right, so the negative terminal is on the bottom. And if you remember, that's the smaller side. So there's our battery. That's the battery symbol from the reference table. Then you come up to a resistor. Okay, resistor looks something like that. Very messy. And then we have a switch. Okay, I'm going to make the switch. Boom. And then we got what is that called? It's called an ammeter. And in your reference table, it's just a circle with an A. And something cool about ammeters is they have to be connected in series. See how they're in a line with the circuit here? Voltmeters have to be connected in parallel. So if I wanted to measure the voltage across that resistor, that's how I would do it. I wouldn't put the voltage in line. Like I wouldn't make this. This is not where the voltmeter goes. Nope, never like that. Okay? So let's see. The ammeter goes in series. I'm getting way sidetracked. Now it says number 3, draw the direction of the current on your diagram. So by convention, the current flows from the positive terminal to the negative terminal. It goes out of positive into negative. And it goes out of positive into the negative. I draw like way too many arrows there, but you get the idea. You could also go boop like that. Call it I. That's another way to do it. Okay. Then it says close the switch. Ooh, I already did that. Was your prediction correct? Are you sure? Let's see. So I think it's going to go clockwise, it looks like. What's happening here? What? Those little things are going counterclockwise. Am I wrong? The physics teacher has become the physics student? No. It says, remember, conventional current is opposite the direction of electron flow. Check this out. If you go on the top right, boom, conventional current, Mr. Nangle's right. Okay? So it goes out of the positive terminal into the negative terminal. So that's how the conventional current goes. I don't know. The default is to have the electrons, and I kind of like that look because it's like, oh, the electrons are moving. That's what the current actually is. Okay, part 2. Nice. Now we're going to use the voltmeter, good, to measure the voltage across the resistor. So I kind of drew that in our circuit diagram before. Let's see, and it says this should be a positive number. So let's see, is it a positive number? How could we make it a positive number? Boom, boom, that's how you do that. Oh man, I got a negative number. So you know what you do? You just go bop, bop, beep, bop. And then, okay, 9 volts right there. Okay, it's measuring the potential difference. Remember, voltage, potential difference between this point and this point. What's the difference in the potential? All right, so we're coming back over here. It says record the current measured by the ammeter and the voltage measured by the voltmeter in the data table to the right. I have to update this because the data table is below and to the left. What kind of sheet is this? So we got 0.9 amps and 9 volts. This is going to be hard for you to do on the sheet if you're working on the Word doc. Oh no, you could just type this. You could type that part in the Word document. The diagram, that might be hard. You could insert a snip of your circuit. And actually, let's see. Do they? Oh, there used to be. Oh, here we go. Boom. If you wanted to insert a snip, I know I'm going way off. Look at that. That looks like a circuit diagram to me with the switch and everything. Okay. So, and then like that. It was on the bottom right. Okay. If you want to do a snip, a little print screen action for the circuit diagram, if you're working on the Word document. Anyway, number 6, add more batteries until you have a total of 5. Record the current and voltage after you add each battery. I'll show you how to do one and let you do the rest of the work because I've done this before. You're the ones who have to do it. So how do you add a battery? You click on this. Either side will do. You cut that out, and now we have space to add in another battery. I'm going to do something crazy right now. Check this out. Oh man, what is happening? That's messed up, Mr. Nangle. What's going on? Why I added another battery? You're telling me there's no current now? Oh, well, look at how you added the batteries. See how they're like, oh, look, it gives you the option. Boom, boom, boom. Okay, you can even change the voltage, but don't change the voltage. We're going to stick with 9-volt batteries. Okay, so that's the idea. You want to make sure that they're like connected in line with each other so that they're helping each other out. You know, let's see, cut. I'm trying to make this a little bit nicer. Okay, so now we could read out the values. We got 18 volts, makes sense, 2 9-volt batteries, 18 volts. And we got ourselves 1.8 amps. Put your I mean, you don't need to put the labels because it's in the top of the graph, the table. Anyway, okay. Plot a voltage versus current graph. Make sure the voltage is on the y-axis, voltage, and the current is on the x-axis. Boom. I don't know how you're gonna do this at home if you're on the Word document. You might not be able to do it on a separate sheet. Take a picture, insert it, or I don't know. Just do it on a separate sheet at least. It's nice. All right, it's a nice thing to do. So, and you count up the number of boxes, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I got 20 nice boxes to work with. And what are we going to do? 9 times 5 is 45. It's going to be, I don't know why this keeps on popping up. Oh my gosh. So you're going to have to figure out a way to do the thing. I don't know. If you need to get up to 50 and you have 20 boxes, let's see. You'll just be short if you go by 2. So you could either make your axes like this, or I think I made this grid so that, I know for me, I like to draw it on the thing, but a lot of my kiddos like to do the numbers off here. So they don't want to make their axes. They're like, oh, let me just use this. So actually, I think I made it so that if you did these as your axes, it works out kind of nice for the numbers. So there's a little pro tip. The voltage, you could go by 2. Figure out what you got to do with the current. It's going to be different. All right, but you're going to get, well, I guess I'll let you try to figure out what should the relationship be. What is that graph going to look like? Okay, and then you're going to do the slope calculation. Remember, slope is the change in y over the change in x. And the y values are going to be the voltage divided by the current. So what is voltage divided by current equal to? It's in your reference table. All right, 8, that's what it is. Calculate the slope of the graph. Show your work on the previous page. What does the slope of the graph represent? That is a good thing. Hint, use Ohm's law in your analysis of the graph. Okay, you can figure that out. Look at your reference table if you need help, okay? What's voltage divided by current equal to? Then it says click on the resistor and select show value. Was your prediction and calculations from step 8 and 9 correct? So, oh yeah, because you can, okay, yeah, I see where this is going. All right, so this is maybe giving it away a little bit, but you could click on this. All right, you don't have to click on show value, I guess, but it shows you some information there. Uh-oh, spoiler alert. Part 3, resistance and resistors. A circuit consists of a 4.5 volt battery and a 200 ohm resistor. Okay, you could do that. Okay, I think you could do all this stuff. What is this about? I didn't even click on this. That's not even a thing anymore. Well, listen, I made this video to show you how the simulator works. I feel like I did that. The rest of this stuff should probably be self-explanatory. Just read through. 15 seems very complicated at first, but it's kind of nice. You're looking at all these different colors, and it's like a data table on what the colors mean. Just look through it carefully, and you should be able to teach yourself. The website's pretty good. So, I think that's about it for this video. It might be my shortest video ever, but I hope it is informative. Hopefully you can see what you need to do with this thing now. Is there anything else that's tricky that sometimes kids do? Sometimes, I don't know, they'll go like this. Oh man, what the heck? It's because there's no resistance anymore. You skipped, this isn't part of your circuit. So you have to make sure one on one side, one on the other side. All right, so if you see that, if it's going crazy and you don't know what to do, disconnect. Something's weird is happening here. So you're going to have to disconnect one of your things and then make sure it's okay, connect one side and then connect, even if you put it over here, it would be good because it's on either side of the resistor. Here it's connected to the same side. You're just skipping that resistor completely. There's no resistance in the circuit, and the electrons are going crazy because there's no resistance. There's a very high current. And I think that might be the only tricky thing. And then I showed you the battery trick. All right, I guess email your teacher if you have any more questions about this stuff. It's a really good lab.